Welcome back, everybody. Continuing Chapter 6 today with Lesson 6.4. We're talking about properties of rhombuses, rectangles, and squares. Okay, now Chapter 6 overall is about polygons, figures with straight edges. And we began by giving you properties of polygons in general. Next thing we did is we moved on to some specific types of polygons, parallelograms, and gave you properties of those. Now, today we're going to move on to some specific types of parallelograms, rhombuses, rectangles, and squares. So all the properties we've given you so far dealing with polygons and parallelograms are still going to apply today. But today we'll look at some specific properties, some specific theorems about rhombuses, rectangles, and squares. Okay, objective to classify and use properties of special types of parallelograms. Let's get going with that. So first thing we'll do today is we will give you a technical math definition for a rhombus, a rectangle, and a square. Now I'm thinking if I showed you a picture of these, you could identify them, but we're going to have to be technical, we're going to have to be precise if we want to actually solve some of the problems we're going to give you today. Okay, so first thing we'll say a rhombus is a parallelogram with four congruent sides. You know, back in elementary school you might have called this a diamond. Okay, we'll call it a rhombus here. And notice with all my definitions, we've got is a parallelogram, is a parallelogram, is a parallelogram. So again, all our properties of parallelograms still apply. Okay, we know parallelograms have two pairs of congruent sides. The rhombus has all four sides congruent. Okay, second, we'll say a rectangle is a parallelogram with four right angles. Now, typically when you think of a rectangle, you'll probably think of the two pairs of opposite congruent sides. Okay, but again, that's true for any parallelogram. So what makes this parallelogram a rectangle is the four right angles is all the angles being equal and equal to 90. Okay, then the last part here is we'll say a square is a parallelogram with four congruent sides and four right angles. So in other words, we can think of a square as both a rhombus and a rectangle. And that'll be kind of how we approach classifying shapes today. To determine whether or not something is a square, we'll check to see if it's a rhombus, we'll check to see if it's a rectangle, and if it's both, that's when we'll call it a square. All right, so before we get into actually doing some problem solving, let's diagram out the relationships that we're dealing with here. Okay, we've made some Venn diagrams in class before, and they're great at showing how different geometric figures relate to each other, especially for this special type of parallelograms we're talking about here. Okay, so let's make a big blob and say that represents all parallelograms. Okay, within that blob, let's make a smaller blob to represent all rhombuses. Okay, the way we have this picture set up, since the rhombus is completely within the parallelogram circle, we can say that if it is a rhombus, we know it's a parallelogram, but there are parallelograms that are not rhombuses. They're represented by all this space outside of that rhombus circle. Okay, now we're going to do the same thing with rectangles. I'm going to make a circle within parallelograms to represent rectangles. I'm going to make it overlap the rhombus circle. And I drew it that way because if it's a rectangle, then it is a parallelogram. And also there are some rectangles that are rhombuses, and there are some rectangles that are not rhombuses. Same thing with rhombuses. Okay, this overlap here, this intersection, we're going to say that is a representation of these squares. Okay, everything that is both a rhombus and a rectangle. Okay, so that's how everything we're talking about today fits together. And it's good to have kind of a good understanding of this relationship, especially when we want to figure out which properties can I use for a given shape, which ones can I use. Okay, it's good to look back at this diagram here. All right, so let's start using those properties. The first thing we're going to do is just classify shapes based on their definitions. Part A is pretty simple. Okay, it says, is parallelogram EFGH a rhombus, rectangle, or square? Explain. Well, I have a parallelogram, And since all four sides are congruent, by definition, that is just a rhombus. Okay, pretty simple, pretty straightforward. Okay, by definition, that one's a rhombus. All right, part B is going to be a little trickier. There's going to be a little more problem solving involved. It says, is parallelogram GHJF a rhombus, rectangle, or square? Explain. So we're given some different information on here. And the key for figuring this out is remembering that this is a parallelogram we're looking at. And there's a few things I know about parallelograms. One, that opposite sides are congruent. Okay, therefore, HJ will be congruent to GF. Same thing, GH will be congruent to FJ. Okay, so since these two consecutive sides are congruent, I know all four sides are congruent. Because it's a parallelogram, therefore I can say I'm looking at a rhombus. Okay, what else though? Notice this angle F in the corner is a right angle. And another thing I know about parallelograms is that opposite angles are congruent. That means that H has to be a right angle as well. I also know that consecutive angles are supplementary, as in they add to 180, meaning that F plus G have to add to 180. Now since F is 90, that means that J has to be 90 as well. And same thing, G will be 90. That means I'm also looking at a rectangle. Now if it's both a rectangle and a rhombus, we won't say it's a rectangle or rhombus, we'll just say it's a square. And again, that's kind of how we'll think about checking for a square. We'll do a rhombus check, we'll do a rectangle check, and if it's both, that's where we'll say it's a square. All right, next thing we're going to do is get into some special properties of rhombuses, rectangles, and squares. Okay, so far what we've done is just use their definitions. Let's get into some properties or some theorems. Okay, we'll start off with a rhombus, and we have a pair of theorems about their diagonals. We're going to say if a parallelogram is a rhombus, then its diagonals are perpendicular. So if we have a rhombus, a parallel with four congruent sides, then when I draw out its diagonals, they're going to be perpendicular to each other. They're going to intersect at right angles. Okay, the other theorem about the diagonal is we'll say that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So as in again, if we have a rhombus, a parallelogram with four congruent sides, and I draw a diagonal, for example, AC, it's going to split angles A and C into four congruent angles. Angles 1, 2, 5, and 6 are all going to be congruent to each other. Okay, that's what we mean by bisect an angle, split into two congruent parts, and both sets of opposite angles will be split into congruent parts. Same thing with diagonal BD, it's going to split angles 3, 4, 7, and 8 into four congruent angles. All right, so when we're talking about rhombuses, we know the diagonals are perpendicular and then also bisect opposite angles. Let's go ahead and use those properties to find the measure of angles now. Problem 2, part A says, what are the measures of the numbered angles in rhombus ABCD? Okay, so it looks like we have a rhombus. We're given an angle of 58, and then we want to figure out the measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. Okay, I can do this in a few different orders. I'm going to start off with angle 1 though. Notice angle 1 is where my diagonals come together. We just said a second ago that the diagonals of a rhombus are perpendicular, so I know that angle 1 is going to be a right angle, in other words, equal to 90 degrees. Okay, what else do those properties give us? Well, we also said that the diagonal of a parallelogram bisect opposite angles, meaning that this diagonal BD is going to split angles B and D into congruent parts. So what I'm going to be left with is four congruent angles. And since I know one of them is 58 degrees, that means they'll all be 58. So 2 is 58 degrees, and 3 is also 58 degrees. Okay? So that's my second rhombus property. And then from there, what I can do to find angle 4 is if I look at this triangle on the bottom of my rhombus, angle 4 is one of its angles, and I already know the other two. So what I can do for angle 4 then is I can just take 180 and subtract the 90 for angle 1 and subtract the 58 for angle 3. So 180 minus 90 minus 58, which will give us 32 degrees for angle 4. All right, so that's an example of how we can use our diagonal properties of a rhombus to piece together what the missing angles are. All right, problem 2 is the same idea. What are the measures of the number of angles in rhombus PQRS? And let's just go through this one together because there's kind of one trick to make this one work where if you don't see it, you're not going to get it. So notice with this one, angles 1, 2, 3, and 4 all lie on the same diagonal. Okay, like we said before, rhombuses, the diagonals bisect opposite angles. So that means that angles 1, 2, 3, and 4 are all going to be congruent to each other. So if we can figure out one of them, we know all 4 of them. How are we going to figure that out then? What we'll do is we'll look at the triangle in the upper left here. We know its angles add to 180 degrees. So if I subtract out the 104 for angle Q, I'm going to be left with the sum of angles 1 and 3. Now since we know those two angles are congruent, if I divide by 2, that's going to give me what each one of the angles are equal to. So 180 minus 104 is going to give me 76. And if I divide that by 2, that's going to give me 38 degrees. Okay, so answer for this one, we can just say angle 1 is equal to angle 2, which is equal to angle 3, which is equal to angle 4, which will be equal to 38 degrees. All right, next up we're going to run through properties of rectangles, and we have one of those for you, dealing with the diagonal once again. We're going to say if a parallelogram is a rectangle, then its diagonals are congruent. So if we have a rectangle, a parallelogram with 4 right angles, that means that my diagonals AC and BD will be congruent to each other. Okay, now we know that with any parallelogram, the diagonals bisect each other. So as in AC would be cut into 2 congruent parts, and BD would be cut into 2 congruent parts. Okay, but with the rectangle, we can do a little better than that since they're equal to each other, since those diagonals are equal. I know we'll get 4 congruent parts, or in other words, 2 congruent diagonals. All right, so let's go ahead and utilize that property here. So problem 3 part A says in rectangle RSBF, SF, so one of my diagonals equals 2x plus 15, and RB, the other diagonal, is 5x minus 12. We want to know what's the length of a diagonal. Now, since we just said that the diagonals in a rectangle are congruent, I can say that SF, the 2x plus 15, is just equal to RB, the 5x minus 12. Okay, so again, since in a rectangle, diagonals are congruent, I can just set those two expressions for the diagonals equal to each other. Okay, let's go ahead and solve this for x. I'm going to subtract 2x from both sides to get the x on the right side of the equation. So it'll give me a 15 is equal to 3x minus 12. I'm going to add 12 to both sides, which will give me that 27 is equal to 3x. Then we can divide both sides by 3 and end up with x is equal to 9. All right, now this one, notice it doesn't just say solve for x, it says what is the length of a diagonal. So what I can do then is I can plug my x value into the expression for the diagonal. And since they're both congruent, it doesn't matter which one I pick. Let's just go with SF. Okay, SF is equal to 2 times the x plus 15. Okay, well in this case, x is a 9 we just solved for. So in other words, SF is equal to 18 plus 15, so 33 units, with whatever units of length we're dealing with. All right, so let's run through problem 3, part B. Okay, different type of problem, so again, we'll run through it together. Along the same lines, we're using algebra and the diagonals of our special parallelograms, though. So B says ABCD is a square. We want to find the value of x. Now, notice the expression with the x in it. This time is an angle, and I can tell that with the degree symbol here. And it looks like it's attached to the angle where the diagonals intersect. Now, if our figure is a square, we know it's also a rhombus. And I know that the diagonals of a rhombus intersect at right angles. So I know that this is going to be a right angle here. So the equation I can set up then is that 6x plus 6 is equal to 90. Okay, because again, I know the diagonals of a rhombus are perpendicular to each other. Let's solve that for x. I'm going to subtract 6 from both sides, which will give me 6x is equal to 84. And we'll divide both sides by 6 to end up with x is equal to 14 for this one here. All right, and the last thing we're going to do is classify parallelograms based on their properties, their special properties, not just the definitions. So let's run through this problem 4 quick. Can you conclude that the parallelogram is a rhombus, rectangle, or square? Okay, let's take a look. I'm going to say part A, I can say this is a rhombus. And I know that because the diagonal bisects a pair of opposite angles. Okay, we have 1, 2, 3, 4 angles all congruent to each other made by the diagonal. That is a property of a rhombus. So I can say the first one's a rhombus. All right, B, what can we say? Well, it looks like the diagonals are perpendicular, just like in the last question. So we know this is a rhombus. Okay, what else do we know? We also know that the diagonals are congruent because they're split into 4 congruent parts. So that means this is also a rectangle. And now instead of saying it's both a rhombus and a rectangle, it's probably simpler just to say a square. So this one is a square because it passes both our kind of rhombus test and rectangle test. All right, moving on to C. C is pretty straightforward. We're not given any markings in the picture, but it just says flat out that SO, one of the diagonals, is equal to or congruent to TP, the other diagonal. Okay, if the diagonals are congruent, we know it is a rectangle. And for the last one, part D, once again we have diagonals that are perpendicular to each other. They come together at a right angle. Okay, that is a property of a rhombus. So we'll call this one a rhombus. All right, so that's it for 6-4, our special parallelograms, rhombuses, rectangles, and squares. Okay, so start cranking away at the homework, start getting your practice in. Let us know if you need any help, and we'll see you folks later. We'll see you for the next lesson.